Okay, so this is the video for my protein project assignment. So my protein that I was assigned is type 1 collagen. Collagen is known as one of the most abundant proteins in the body. The mutation that I was assigned along with it is a dominant negative substitution of glycine for a larger amino acid in several different locations. So when I did what is the normal function of the protein, like um like the type of function it holds, structural enzyme, etc. So I said that collagen is a structural protein that strengthens the tendons by forming molecular cables. It also forms sheets that help support skin and internal organs. Where is this protein normally found? In subcellular locations, types of cells that contain it, types of organisms, and all that. So on the subcellular level, collagen can be found in the rough ER, where it's usually synthesized, and in the intracellular matrix, where it helps form connections between different cells. Collagen is mostly found in fibroblast cells, which are primarily found in connective tissues. Once I said again, it is most abundant. It's the most abundant protein that is found in animal cells, so like mammals, birds, all that stuff. When I categorize the type of mutation it has on the protein function, the protein becomes less active. And I say this because the production of collagen is lessened because when glycine is substituted for a larger amino acid, normally cysteine is what it's substituted for, the structure of the triple helix is disrupted, obstructing the normal collagen assembly, overall reducing its production. Okay, so the main functional groups present in the original amino acid side chain are amide and hydroxyl groups. And for it being hydrophobic or hydrophilic, collagen is an amphipathic protein due to its hydrophobic and hydrophilic properties. Collagen's charge is usually depending on the pH level of its surrounding area, but it tends to stay neutral most of the time. Characterizing its size compared to the other standard amino acids, I would say that it's a small, because like glycine and like proline are like two of the smallest amino acids there are. For interactions, the type of interactions that it can participate in are like there are non-covalent hydrogen bonds between like neighboring collagen proteins that contribute to the stability of collagen fibrils. Collagen fibrils are basically when a different bunch of proteins get together and form like a bigger collagen type of thing. I need to use a better word. I'm sorry. The main functional groups present in the mutated side chain, when it's replaced with cysteine, the new functional group introduced would be a sulfhydryl group, just to like sulfur and stuff like that, and cysteine. Collagen tends to become more polar when cysteine replaces the glycine amino acid in the mutated. And the mutation involving cysteine does not really have a strong effect on the charge because cysteine is an uncharged amino acid like most amino acids are, keeping the protein rather neutral still. Because of this substitution of cysteine, I will categorize it as relatively large because cysteine is on the bigger end of amino acids. And because of the mutation, the hydrogen bonds that help the proteins be stable with one another are thrown off now, causing an imbalance of the collagen fibrils actually being produced. And I need to go back. And like the mutation of cysteine being replaced with with glycine being replaced with cysteine is disease. That's what it usually causes. And I'll get into that in a second. Okay. For how does your assigned mutation affect the protein function, the function of the cell, and the function of the organism? When glycine is replaced, the protein becomes irregular shaped and production of collagen is significantly reduced in the body because collagen makes up 40% of a bone structure. When it isn't formed properly, it causes a weakening of the bones, resulting in easy fractures occurring within the body. So, yeah. The overall 3D shape of collagen is like a triple helix, as you can see here. Like the triple helix is made out of, I'm going to show you this way. The triple helix is like this right here, like, there's a little spiral. And these are peptide. Oh, okay, hold on. Like peptide chains. The peptide chains are made up out of the amino acids. So it's usually like glycine, proline, and hydroxyproline. So that's what these are right here. So it's glycine, proline, and then hydroxyproline, and then it's like glycine is at every third, so it just repeats itself. And then as you can see, this is the mutated one. So when you have the mutated one, it replaces the glycine in all of its spots. So this would be like cysteine, proline, hydroxyproline, then cysteine again, and so on. So to use this, like to make my model, I use pipe cleaners and pom-poms basically because it was like the most resourceful thing that I had. But yeah, so the subunits in collagen are the 3 peptide bonds that form the triple helix. That's what I was showing y'all there just now. So yeah, when the collagen is mutated, its formation of the triple helix is disrupted, which usually leads to like kinks and instability that impair the assembly of the collagen fibrils. So that's why I decided to build 2 different models to almost like showcase that. And yeah, so the mutated amino acid is in the triple helical domain in the position of glycine. So like right here, like I showed them, like usually you won't really like see them, like they're not like on the outside, they're really like in the peptide bonds, and the peptide bonds will really be like kinked out. But I put like the pom-poms there just to show you where the actual like amino acids will like, be at. The main limitation I have with creating these models is showing the actual like distorted shape that would occur when the mutated amino acid took the place of glycine. So in this mutated model right here, it would usually be like distorted. Like it wouldn't be like, say that this was like perfect shape right here, the perfect triple helix and all that is tightly packed. This one with this replacement with the cysteine, it would be usually like kinks and disformed, disfigured, and so it wouldn't fit properly with other collagen proteins. So yeah, that's my spiel. Thank you.